It is 2 hours UTC, and it's time again for Astronomy Daily Live. Hey, everybody. Hope everybody's doing well. You can call me Cosmic. And look, I shaved a little bit. Yeah. Hey, it's you know, uh, if if this is the worst thing that us guys have to deal with, I will take it. I will take it. Yeah, not a big pain. I do it the lazy way anyway. I guess it's the fad now, right? To sort of be a little scruffy. So I've had the scruff look for mm, 30 years. So yeah, fads come and go, but not me. so, so yeah, I hope everybody's doing well. I'm going to tweet the fact that I'm live now, and I'm going to make sure that that isn't going. Yay! And I'm going to pop out my chat. Hey there, Bobby Burgess. Nice to see you back in the chat again. Hey, I watched Fraser Cain's. Well, I started to watch at least Fraser Cain's Q&A today. Hey there, Tom. Nice to see you in the chat. Um, and he's talking to Cody's Lab. Cody's Lab. So check that out. It looks pretty interesting. Looks like Cody's been doing this for like seven or 8 years. He's got like 1.4 million subscribers, and he just does like um, little chemical experiments. Not exactly sure. Looks pretty intriguing. Just saw it for the first time maybe an hour ago or so. So I still need to uh, check that out. But yeah, looks pretty cool. You know, it's a sciencey thing, and so yeah, I'm definitely going to check him out and see what Cody's Lab is all about. But check him out on YouTube, Cody's Lab. Check out Fraser Cain as well. Um, what's his what's his uh, what's his thing? I don't know. I guess it's just. Oh, I got to go through the ads here. Got to do all the ads, YouTube ads, skip ad. Just Fraser Cain. Yeah, just Fraser Cain. So check both of those guys out. Looks pretty interesting. I've been following Fraser for a number of years. So yeah, he's awesome. He's awesome. If you haven't checked out Fraser Cain yet, definitely, he's yeah, very awesome science communicator and enthusiast with all things space and astronomy. So yeah, I hope everybody's doing well. Cheers! It is hydrogen hydroxide tonight. Cheers. Yeah, Fraser's also on the weekly space hangout and astronomy cast. So check those ones out as well. Thank you, Uncle Bill, for the reminder of that. Nerd hype for sure. Nerd hype for sure. Yeah, always have been, always will be. It is the uh, our society, our culture is a is the triumph um, of the nerds. So it wasn't for the nerds of the world. Um, dare I say, we would still be in the dark ages. So yeah, we need some nerd hype out there. So always willing to throw in for some extra nerd. And you know, I'll say this a million times. Not everybody has to be interested in science. Not everybody has to be a nerd. Just like not everybody has to be a baseball player, right? And not everybody has to be a garbage man. Um, and not everybody has to be, a, a flight controller, right? Not everybody does. But the thing is to find is to find what you like to do, that you can just do it. Just it's not work to have to do what you love doing. And I can say that for I would say probably 90%, maybe um, probably between 90 and 95% of my adult life, I I I've uh, just had a lot of fun. I haven't really worked. They they've been foolish enough to pay me, to do the kinds of things that I thoroughly enjoy. And to this day, they're paying me to just have a blast, right? So if you can find that, then you know do it. But so not everybody has to be, you know, um, completely interested in science or technology or anything else. There's going to be a group that is, and there's going to be a group that isn't. And as long as those who aren't sort of being a drag, right, on those that are, then it's very cool, right? And that goes for anything, right? Um, so yeah. Okay, yeah. So Cody's lab is backyard chemistry, mining, beekeeping, gardening, lots and lots of stuff. So yeah. Uh, cool. Well, he seems to have obviously, quite a following, and he's been doing it a while, and I definitely want to see if I can, extract some gems from his methods, to see how he's maintaining um, what his frequency is. I didn't even get a chance to see how often he posts, right? But yeah, the one thing that I did see from what like the first 5 or 10 minutes of the interview that I saw is that consistency is a really important thing, and I've known that for a long time. I mean, I've been uh, I actually had a YouTube channel starting in, I want to say 2009. 2009, um, more leading towards gardening, market gardening. Was it 2009, 2007, 2007, 2009? I forget exactly. Um, and yeah, gardening and that that whole adventure I've sort of put off to the side. Haven't been doing a lot of gardening in recent years. Hopefully going to get something going pretty small this year, but yeah, back in 2003 to 2006 or so, 2000, yeah, mid 2000s or so, I actually ran a market garden, where I grew a bunch of different things, veggies, organically, and sold them in the various markets. I was actually selling to stores in Tucson, and also at two of the markets there, and that was a lot of fun. It was a lot of work, and yeah, I just basically stopped. We in 2005 we moved here, and that sort of put a uh, um, sort of a stop to at least the market stuff. Um, Garden for a little while after that, and then yeah, just uh, moved on to other things. So Cody's B Lab, Cody's B Lab. Um, okay, yeah. When the main channel gets shut down, why does the main channel get shut down? Is this a regular thing, Uncle Bill? What's going on there? Oh, it's been demonetized and completely locked out multiple times in the past year simply for being real. Huh? That seems a, a little strange. It's yeah, maybe that's one of the hazards of having 1.4 million subscribers is that you get some rotten apples in there that unfortunately are pretty distressed people, I think, and you know when um, I don't know who who it was exactly. Maybe it was like Ram Dass or something, but you know uh, it's like, okay, if you've got an orange, right, and you squeeze it, you're not going to get apple juice out of it. You're not going to get grape juice out of it. You're going to get whatever's inside, right? So you're going to get orange juice. So that sort of works with people too, right? Whatever's inside uh, uh, is what's going to come out as well. So the anger and the fear and the that form of entertainment is what is inside of them, and that's what comes out. Um, so yeah, okay. So yeah, somehow the so-called flat earthers have um, targeted his channel and had it shut down a few times. Wow, that's uh, that's pretty intense. That's pretty intense, I'll have to say. So I but anyway, so yeah, I'm always glad to make new personal discoveries about that. He's been on for a long time and seems to know what he's doing. So yeah, I will just sit back and watch and learn if he's doing good science, and especially most importantly, if he's having a good time, then more power to him. Cheers. The fact that it's called Cody's B Lab um, says a lot. Yeah, it's like you know that's that's really uh, that's very much a scientific type of a thing, right? Cody's B Lab. Once that gets knocked down, there'll be Cody's C Lab and Cody's D Lab. It just goes on and on like that. So that's very very cool. So yeah, trying to think if there's anything. I posted a number of interesting papers over on my Discord server that I encourage you to take a look at. mining and chemistry and explosives on occasion. Okay, yeah, understandable. Hopefully he's doing that kind of stuff in sort of a responsible way that is obvious, right? I mean, he's not purposely trying to hurt himself or um, others or cause any kind of destruction and stuff. He's doing chemistry, and chemistry is what it is, right? um, so yeah, blab, yeah, blog or vlog, yeah, a blab. That's awesome. Done like a true scientist, a true nerd, mixing words. Yeah, that's awesome. That's awesome. I I think I'm gonna like him. Yeah. Bobby, I don't know. I don't know what's going on there. About a week ago or so, um, I went over to YouTube's about page and actually on this live stream read their mission, and yeah, it's the sort of the stories that I've been hearing about channels being shut down and all that seems to almost be contrary to what they're sorry about that pop um, sort of contrary to what their mission states. So yeah, going on there. Um, there are certain channels that have been shut down, and certain ones that are sort of like the same topics that aren't being shut down. So it's kind of strange. Yeah. Don't know what the formula is for shutdown, but yeah, I'm personally for this channel. I'm not too worried about it yet, and I uh, I don't see any reason, to push any kind of limits in terms of rules or anything like that, because I'm here, sharing a passion, sharing the passion that is the science of astronomy. That's very, very true. It's very true, very, very true. It's sort of like you know um, uh, um, statutes or laws, and then administrative law. And administrative law is you know pretty much anything goes, and then you have your statutes, that says things like, make laws that are for this, and then the administrative laws pop in and can be quite insane. So yeah, maybe that's what's going on. It's a little weird. It I'm interested in understanding how that's being policed. If that's mainly being policed by bots, but even so, you know, it's you know if if the bots are tuned, um, to sort of a certain sensitivity, then it's going. I mean, eventually, I would think that it would come back to some kind of a human, and an evaluation would have to be made. But maybe maybe they're, you know, doing an experiment to see, you know, how well, you know, these bots uh, are behaving, how fast they learn. You know, we are moving into the age of AI, right? So you know, or at minimum, you know, machine learning, and you know what better way, you know, to teach a machine about human behavior than to let that machine watch all this YouTube stuff. And you know, those machines can watch, you know, multiple channels at the same time, right? And you'll be able to process them, um, mainly because you know they're just so much faster. So yeah, we'll see where all this goes. It's you know, I mean, YouTube has this forum, right? This platform um, that, at least according to their mission, is, and um, I'm paraphrasing here, but is, you know, open to expression and you know, not wanting to interfere and all of that. So mm, don't know. I mean, I guess one does have to draw the line somewhere. I'm not exactly sure why, because you know, I guess my attitude is that, you know, if people want to watch and see a particular thing, then you know, let them, right? It's hard, it's hard to judge those kinds of things. You know, even when it comes to things, you know, that you know, may be, you know, distasteful, or um, but you know, it's like, well, if you don't like it, don't watch it. You know, don't support it. And and if it's a thing that you know, um, um, culture and society just doesn't approve of, then they won't get the views, right? And they'll stop, right? That's sort of the idea. But yeah, you know, one of the things that always gets at least us humans really excited is these extreme things, right? Because it offends us and it upsets us and all of that. So yeah, I don't know. Anyway, this Astronomy Daily Live is about all things astronomical. So let's get into some astronomy. And what I thought I would do is let I, I wanted to do another object of the day based on a constellation. And I wanted to focus on the constellation itself a little bit more. So let's do that. I've got my list of constellations here. The International Astronomical Union has decided that there are 88 constellations. So I'm going to share my screen like that. And we're going to go over to random.org. And I have on my Linux machine over to my left here an alphabetical list of those 88 constellations. Do is I'm going to ask random.org to choose an integer between 1 and 88. And that will choose for us our constellation of the day. Constellation of the day. And then I guess if we get incredibly bored and run out of things, then maybe we can find an interesting object inside of that constellation to 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 sort of dive into a little deeper. But yeah, let's keep it a little bit light tonight. I know I can get um, pretty heavy into things. Let's just focus on the sky, because the sky is awesome. You know, I am lucky enough to uh, have been able to locate myself pretty much anywhere I wanted on the planet. And I've chosen southeastern Arizona in the United States because it's dark. Number one, it's dark, and number two, it's nice and quiet. So I'm lucky enough that I can just walk out my door, my front door or my back door, and I am in darkness, really dark. Right, this is one of the darkest uh, locations, at least on this continent. Right, so but not everybody is that lucky. I grew up in a city, and could probably see down to maybe third or fourth magnitude, maybe fourth, maybe. Um, the human eye can see down to about magnitude 6 or so. Um, so, not too bad, but I still remember the first time I really went out to a very, very, very dark site. And man, I mean, got to admit it, right? I mean, um, I'd been into astronomy for several years by then. Thought I knew the sky pretty well, right? But when I got out under that dark sky, I was lost. I was really lost. I mean, I could not find very, very familiar constellations. I mean, it took me a while. So, but now I'm lucky enough that I'm out in the dark. I can see every constellation there is. Well, of course, I can't see all of them because some of them are south of me, and so I'm not able to see them. But all right, let's pick one, and then I'll go to my alphabetical list here, and we can keep going from there. So drum roll, please. Number 51. Okay, so on my list, number 51 is the constellation of Lynx, Lynx. So let's go over here, and what I found is that actually Wikipedia usually has a pretty good map. Lynx constellation. Oops, constellation. Yeah, there we go. Introduced in the late 17th century by Johannes Hevelius. It's a faint constellation with its brightest stars forming a zigzag line. Orange giant Alpha Lyncus is the brightest star. Semi-regular variable. 6 star systems have been found to contain planets. So here are the borders of the constellation of Lynx. And as you can see, right, Lynx is a pretty high declination constellation, right? We can see this from any of the northern latitudes. I mean, here's Gemini way down here, right? Here's Cancer, here's Leo over here. But there's lonely old Lynx, not the most exciting not the most exciting constellation. Look, it's right between Ursa Major and Auriga. Auriga also has the star Capella in it. It's a big bright red star just north of Orion. Auriga also has at least three of the Messier objects, M36, M37, and M38. It's got a bunch of other things too. But let's look at Lynx. So typically how these stars are sort of named, at least their first names, is by the order of the brightness of the stars. So as you can see, this is Alpha Lynx because it's the brightest star in that constellation, right? So for those of you who aren't familiar with reading these kinds of charts, right? These dots represent the positions of stars, and then the size of the dot um, gives you an idea about how bright it is. So you can sort of see that these two stars here, right, are bigger than this star, which means that these two stars are brighter than that star. That's all that really means. So, and it's sort of a reverse thing, right? You know, the more black they are, the brighter they are as well. Now I'm going to go back onto my chat to make sure that I'm not being taken over by by anybody. There's oh man. Anyway, hey there, Hip. How you doing tonight? Hope everything is well. YouTube not going in the right direction, it seems. Yeah. Um, yeah. Cloudflare maintains a similar system of lava lamps for securing approximately 10% of the internet's traffic. Huh. Okay. Not following you there exactly, Hip, but I'll go with you. So yeah. Anyway, so we're looking at the constellation of Lynx, easily viewable in the northern hemisphere. In fact, if it's dark where you are right now, you can go outside and look. Oh, I don't know, sort of towards your northwest, pretty high up, and that's where it, um, that's where it is. See, it's right between um, Ursa Major, which we would call the Big Dipper, and Gemini. So it's pretty big. Lots of, these are sort of the main stars. These are what I would call the visible stars, right? The ones that are connected here. But of course, there's a bunch of other stars as well. So let's see if Wikipedia has any other interesting. What happened? Whoop. Oh. Because probably what I want to do is I'm going to want to go to Burnham's Celestial Handbook and see what's going on there. So it's the 28th largest constellation. It says there 4 main stars, 6 stars with planets, supposed planets. 1 star is pretty close, within 32.6 light years away. So kind of interesting that Alpha Lynx has a visual magnitude of 3.14. That's kind of a nerdy number. No Messier objects, but I'm sure there's other interesting things there. Let's see, notable features. Sky objects, NGC 2419. Looks like it's a globular cluster. So this is one of the most distant known globular clusters within our galaxy. NGC 2419 is likely a highly elliptical orbit around Milky Way, a magnitude of 10.3, which, yeah, that's pretty faint. It's not the faintest globular cluster. Extremely concentrated at its center. Originally thought to be a star, NGC 2419, discovered to be a globular cluster by Carl Lampland. The blue compact dwarf galaxy, NGC 2537. Okay. IC 2233, flat thin spiral. NGC 2841. It's a group of galaxies. Cool. I wonder if they're, yeah, I guess it is an actual physical group. That's sort of what it's indicating here. Looks like NGC 2770 spiral galaxy had a few supernovae in them. That's pretty cool. Type 1b, which means it was a white dwarf going around another star. Material fell onto the white dwarf until there was enough mass to make it go boom. Very cool. Cool. Thanks, Uncle Bill, for the shots on Discord. You demand. Very distant broad absorption quasar. Lynx supercluster. Cool. It was the most distant supercluster known at the time of its discovery in 1999. Smaller clumps. Further still lies the Lynx arc, located around 12 billion light years away. Holy moly. It's a distant region containing 1 million extremely hot young blue stars with a surface temperature between 80,000 and 100,000 K that are twice as hot as similar stars in the Milky Way. Pretty cool. I think there's meteor showers associated with Lynx. That's kind of cool. We can let's see, what direction should we go? I'm sort of inclined to take a look at this this furthest known globular, or one of the most distant known globular clusters in our galaxy, NGC 2419. Sounds pretty interesting. But what I want to do first, I'm you know, I've got my biases, as we all do. And what I want to do is I want to go to Burnham's Celestial Handbook and see what Burnham's has to say about Lynx as well. So I'm looking down here on the floor at my spread of books. And is this one? No, it's got to be in volume 2. Now, volume 2 still has the back cover on it, and the, not exactly the binding, but just the binding cover on it. There's no front page left. So that's when books get used. So that's how it goes. No respect for book covers. What I usually do, I don't have an example here, you know, but if I get a book that has a what are those called, like a dust jacket, you know, the thing on top. First thing I do when I get them home is I remove that, because I know that it's not going to last. So let's go to Lynx here. Lupus Lynx. Here we go. So Burnham's also lists all the binary stars, all the multiple stars, and there's 2.5 pages of multiple stars. Here's the first page. Back up a little bit. So there's the first page of multiple stars. Usually these are binary stars. And then here's page 2 and page 2.5. So lots of binary stars. Let's see if there's anything that pops out here in terms of separations or brightnesses. Looks like they're all, 6th, 7th, 8th magnitude primary stars, 9th, 10th, 11th secondary stars. Some of them are triple stars. Yeah. So here's a bunch of variable stars in the constellation of Lynx above my wiggling finger there. And then here and over here are all the non-stellar objects. And as you can see, there's one globular there. Looks like there's a planetary nebula. And then the rest of these are galaxies. So what's the planetary nebula? It's NGC 2474. It's got a 17th magnitude central star. Pretty faint. Okay, so here's a little blurb on NGC 2419. This is the one that they were talking about, right? One of the most distant. I'm looking at the Wikipedia. Yeah. Okay. So this is a Burnham's drawing of NGC 2419 relative to our galaxy. So you can see it's way over there compared to where our galaxy is. So wow, it's way out there. Holy moly. Holy moly. What'd they say? What'd they say? Yeah, between 275,000 and 300,000 light years from Earth. Okay. Well, supposedly the apparent diameter of the Milky Way galaxy is it's like 100,000 light years or so. So yeah, this is like three times the diameter of the Milky Way. It's man, I would almost say that that's not really necessarily associated with the Milky Way. What would be really, really interesting, right, is to go to Gaia, data release 2, find the stars in NGC 2419 and see how they're moving. See, we wouldn't be able to get a parallax, but we would be able to get like a radial velocity and see if it's moving towards us or away from us. That might be interesting. So why don't we do that? Let's take a look. Yeah, we've got a little bit of time left. So let me share my screen and let's look at NGC 2419. Now, according to Burnham's, NGC 2419 is about 7 degrees north of Castor in the constellation of Gemini. This is the famous intergalactic wanderer, it says. And at least according to Burnham's, it is the most distant of the Milky Way's globular star clusters. They're calling it an extragalactic object, though, an extragalactic object. So very, very cool. Discovered in 1788 by William Herschel. Who else? Of course, they never mentioned his sister, who took all the notes, right, and also made several of the observations. But I will mention her because, yeah, somebody's got to do that. You know, I mean, it's extremely convenient. Having done this, right? It's extremely convenient to be able to look through your scope and be able to say out loud what you're seeing instead of having to look through your scope, write some notes, look through your scope, write some more notes, look through your scope like this. So, you know, to have an assistant like that taking notes, awesome. Thank you, thank you, thank you for doing that. Lord Ross, located nearly opposite the galactic center. Yeah. Oh. Well, let's now look. Here's a picture, a photograph of NGC 2419 taken through the 42-inch reflector at Lowell Observatory. Check that out. Now, I'm not going to claim that that is probably the best that they could do, but I noticed on Wikipedia they have this. I'd say that looks a little nicer. Look at all those red stars in there. Wow. Fabulous. Fabulous. All right, well, why don't we take a look at this a little more carefully here, huh? We've got a few minutes left. Let's go over to Simbad and check out this most distant globular cluster, NGC 2419. Yeah. Let's go over to Simbad. And we'll do a search for NGC 2419. NGC 2419. Globular cluster. Right ascension, 7 hours, 38 minutes, 8.51 seconds. Declination, positive 38 degrees, 52 minutes, 54.9 seconds. And it looks like it's moving towards us. You know, our relative motion is such that this globular cluster appears to be moving towards us at about 20 kilometers per second. And so really the only magnitude that we can be sure of visually is this V magnitude. That's a filter, a pretty broadband filter that is centered on, I believe, about 5,500 angstroms or so. K is definitely quite a red filter. G is about the same as V, more or less. R is pretty red. I think that's about 6,500 angstroms. And then I and Z are definitely towards the infrared. So you can see that it's actually brightest in K, in the K band. Here's some other names for NGC 2419. Not too many, strangely enough. Oh yeah, quite a few references. Not too surprised at that. We'll come back to those in a second. let's see. They've measured distances apparently. 0.083 megaparsecs. It always forced me to get my calculator out, which of course I always have within arm's reach when I'm at this desk. So a megaparsec is 3.26 million light years. And so we're going to multiply that by 0.083, 0.083 to get 270,580 light years. So that's as of 2008, right? Now, I think, I don't, yeah, Gaia, I don't think the Gaia data is going to be able to tell us anything about distances. I don't think so. I'm going to put Burnham's back down on the floor there so I can find it. And let's see, are there any other, doesn't look like there's any observations, anything like that. We can go over to Ned and see if Ned has anything more to say before we go into the pictures and the references. Pretty much the same info as before. Okay. All right, let's take a look at the pictures. We got to look at pictures. It's always going to be zoomed in here first. We can zoom out. You can see that the center here in this image, at least, is overexposed. So this is probably like the Sloan Digital Sky Survey image. It might be Palomar, but it's probably Sloan. It's probably SDSS. But yeah, you can see the same star patterns, of course. Let's zoom out one more time, and then we can sort of scan around and see if there's anything else moderately interesting in the area. It's got to be a pretty easy object to find if you're a star hopper, right? Just got to find these two stars, and it's right next door. That makes it pretty easy to find. Ooh, there's a nice little galaxy up there. Cool. Looks like maybe an edge-on spiral. Let's keep going that way. Let me see much of anything else. Just a bunch of stars. Here's like a snowman here. So all of these stars that we're seeing here are inside of our galaxy, inside of the Milky Way. So we're sort of looking through the Milky Way to space beyond. And that galaxy that we saw, of course, is a space beyond. This looks like there's a cluster of galaxies here. I don't know why that's jumping around so much. Let's zoom in a little bit and see. Yeah, there's a little cluster of galaxies there. Come on. All I see is blackness. Come on. Oh, I see. It's zoomed in too much. Yeah, there's a nice, maybe a cluster of galaxies, and sort of get an idea of maybe that they're associated with one another because they're more or less the same brightness, more or less the same size, but there's quite a few, right? Now that looks like a star, but that looks like a galaxy, probably an elliptical galaxy, this one and this one. This one maybe is an elliptical, maybe spiral. The rest of these look look spirally. Kind of cool. Maybe that's one of the clusters that the Wikipedia uh, article was saying it. Hey there, Hip. Take care. See you later. Come back to the porch whenever you want. This is a circle of friends. We just sit around, look at galaxies, look at globular clusters. What could be better? Now I've completely lost my place. Oh, there's something interesting over here though too. You know, we got to follow our noses here a little bit. That's pretty cool. Don't know what's going on there. Huh. That's a pretty weird looking I don't know what you'd call that. My first inclination is that these two objects aren't necessarily, you know, associated with or interacting with each other. Just, you know, one is in front of the other. But I'm looking at this thing going, seems to be some star forming regions there. There's no spiral arms. So yeah, you know, maybe there's some interaction. Look how this galaxy is just like cut off right there. Now that could be an artifact from the image itself. Or yeah, you know, maybe they are interacting and you know, deforming each other. Kind of strange. This is a beautiful spiral back here. Look at that. Wow, that's like a textbook spiral back there. That's awesome. You can even, I'm sort of getting a little hint of maybe red in the middle there. A little bit of red. Yeah, very cool. Very cool. It's fun. It's fun to have these kinds of distractions. Yeah, that's like a textbook spiral there, almost. Look, it's got some brightening, or you know, like a blob up here where there isn't one over here. So pretty cool. All right, well, I'm completely lost. Where's our globular cluster? Completely lost it. There it is. Now, at this scale, right, at this scale, you can really see why it could be mistaken for a star, right? Because it's small and bright. But there it is right there. So we'll put that in the center so it zooms in properly. That's a pretty little spiral, though. Definitely pretty. I wonder. I'm curious now to see uh, how many of these stars are actually in the Gaia catalog as well. Don't know. All right, let's go back and look at some of the references, see if there's anything interesting there in terms of research that's been done on this most distant globular cluster. Asymmetric tails of globular cluster streams. Now, for some reason, this paper is about NGC 6402, but maybe somewhere in it, it has a reference to 2419. Let's see, gas explosion in Mond, Milky Way globular cluster metallicity, wandering off the center, a characterization of the random motion of intermediate black holes in star clusters. Yeah, there's this idea now that some globular clusters host so-called black holes. Another tidal tail. I'm not quite sure why they're anything. Let's see, the power of teaming up HST and Gaia, the first proper motion measurement of the distant cluster NGC 2419. Hey, let's take a look at that one, eh? Let's go right to the paper. Skip all this fluff. Power of teaming up HST and Gaia, the first proper motion measurement of the distant cluster 2419. Aims. We present the first measurement of the proper motion and orbit of the very distant and intriguing globular cluster NGC 2419. Methods. We've combined data from HST and Gaia data release 1 to derive the relative proper motions of stars in the direction to the cluster. Tied to an absolute reference frame, we've used a background galaxy located in the field. Results, we find the absolute proper motion of NGC 2419 to be, so in right ascension, it looks like it's moving to the west at 0.17 milliarc seconds per year, and it's moving down south in declination 49 milliarc seconds per year. But you can see that the error bar here in terms of right ascension is actually larger than the number itself. So yeah, you got to take these numbers with sort of a grain of salt. These give you a range, right? These give you a range. So what that is going to be either negative 0.17 plus 0.26, 0.17 negative plus 0.26. So it could be moving, whoop, I did that wrong, 0.17 negative plus 0.26. So it could be moving 0.09 milliarc seconds per year to the east, or it could be moving, what is that, 43.43 milliarc seconds per year to the west, right? So yeah, it's a big range, but we're also talking about very, very, very small numbers, right? That's fractions of a thousandth of an arc second. So, we're talking about micro arc seconds here. 170 micro arc seconds. That's hard to measure, and that's why these numbers are so large, because that's just hard to measure. You need high resolution, lots and lots and lots of data. Anyway, let's see. We've integrated the orbit of the cluster in a galactic potential and found it to oscillate between 53,000 parsecs and 98,000 parsecs on a nearly polar orbit. This makes it likely that NGC 2419 is a former cluster of the Sagittarius dwarf spheroidal galaxy. Isn't the Sagittarius dwarf spheroidal galaxy, isn't that the one that's being ripped apart, sort of arrowing through the center of the Milky Way right now? Can't be sure. Let's take a quick look at the paper. This was published back in 2016, so it's pretty recent. Proper motions are extremely powerful tool to investigate the evolution of the Milky Way and its satellites. Okay, yeah. In this work, we described the first combination of data sets from HST and Gaia to measure the proper motion and determine the orbit of the enigmatic cluster NGC 2419. NGC 2419 is by far the brightest globular cluster in the outer regions of the Milky Way halo. Cool. I want to see some HST images. Let's see. I hope that we have some of that. Yeah, okay, so here's some, so here are the measurements of the proper motions itself. And see here, you can sort of see the error bars associated with that. So it's moving somewhere in that vicinity. Proper motion, proper motion. Okay, so here's the background galaxy that they use to uh, they sort of assumed that this galaxy was stationary, and so they did their astrometry um, based on the position of this background galaxy. That's sort of a clever way to do it. So by combining the above measurements with the cluster's radial velocity and sky position, they're able to determine for the first time the orbit. Now, I don't know. I don't think that there's enough. There's probably not enough data there to really get a good orbit. It's sort of like those. The other day we were over on spaceweather.com, and they show the supposed orbits of the meteors. You know, when they come in, and you know, we make an observation of a meteor, and we see, you know, a few kilometers, you know, its last few kilometers, right, in an orbit that is millions and millions and millions of kilometers long. So, you know, to be able to nail down an orbit, okay, maybe sort of gives you a little bit of an indication, sort of. But, you know, go for it. Just show your error bars, right? Just show your error bars, and I have no problem at all. Good for them. See that? See? I'm going to zoom out here a little bit. See, this to me is acceptable, right? Trajectory on the sky of NGC 2419's possible orbits, and you know, look at the range. Look at the incredible range, right? So, okay, they've done things, at least according to Cosmic, they've done things right. Yeah, so suggested that it may have been a globular cluster associated with the dwarf spheroidal galaxy Sagittarius that was lost as soon as it entered the potential well of the Milky Way. Our proper motion measurements show that the sense of the rotation of Sagittarius and NGC 2419 about the galactic center are the same, and therefore an association appears rather likely. Cool. So this globular cluster was associated with a dwarf galaxy, companion galaxy to the Milky Way, until that dwarf galaxy sort of got sucked into the Milky Way, and this globular was sort of thrown out. Very cool. Conclusions. We presented the first measurement of the proper motions of the intriguing globular cluster. So that's pretty funny, right? They call it a, okay, so here they call it an intriguing globular cluster. They called it a, um, they called it a couple other things, right? So yeah, all kinds of adjectives to describe this globular cluster. Numerical um, integration of the possible orbits and the galactic potential starting from the current location and the velocity. Um, yeah, so very, very cool. This, of course, I would say is, the center of the galaxy. Maybe this is hard to tell. I'm seeing 180 degrees here, so maybe this is the center of the galaxy over here. So yeah, it could be in a polar orbit, could be more in like an elliptical orbit. Hard to tell, not enough data there, but at least they're showing it correctly, right? Here's the range of possible orbits. And I like that. I like that. It's not like, okay, here's the orbit, because there's just not enough data there to be able to do that. Very likely that NGC 2419 originated in the Sagittarius system. Cool. Very cool. Nice. All right. Well, I think that's enough for tonight. We've been going at it for a little while. As I said, I didn't want to get too heavy, too heavy tonight. Just chose a random constellation, the constellation of Lynx, and then found an interesting object inside of that constellation. And you know, uh, those objects don't have to be non-stellar objects. They could be stars as well. There are trillions and trillions and trillions of interesting things out there. So you know, more than enough, to cover a daily live stream. So easy peasy, and lots of fun. And we get to think astronomical things. We get to think far out stuff. And this is one of the farthest out globular clusters that we know of that is still sort of associated with the Milky Way galaxy. Now we can see globular clusters um, uh, in other galaxies, no problem. But that's sort of way over there, right? This globular cluster seems to be associated with us in some way. Also seems to be moving towards us, or maybe we're moving towards it. So it isn't maybe necessarily a runaway, but it definitely has sort of been thrown out um, into at least a very, very odd, big, big orbit. So, and one of the cool things is, right, is that this is a pretty bright object. So with this scope, very, very easily, I could see that object. In fact, I'm sure I probably have. So, very, very cool. Very cool. All right. Well, I'm going to get out of here for now. Thanks for stopping in. Thanks for watching. If you're new here and like what you're seeing, hit the subscribe button. You can hit the like. You can hit the don't like, whichever you prefer. Share this video around. If I'm trying to find my core group, right? I'm trying to find my core group, a group of people who sort of share a similar passion, or at least have a strong interest in this kind of content, this kind of a delivery. Now, I am not a science communicator. I'm not a um, um, educator. I I like to share my passion, and I've been doing astronomy my entire life at every single level. Right? I was new I've been an amateur. I've been a pro. I'm all of those things. I'm all of those things. I don't claim to be an expert in anything at all. If I ever claim to be an expert, tap me on the head and kind of go, no, wait a minute, you're a what? Because yeah, I not going to claim. I can sort of pass information along. I can speculate. I can do those kinds of things. But mostly, what I'm going to be doing is going, wow, wow, that is very very cool. That's very very cool. I've studied this kind of stuff enough to have sort of a meager understanding, and so I can appreciate things maybe a little bit more than normal. So I can sort of pass that on to you as well. But yeah, I'm just a nerdy old scientist who is blown away by pretty much everything. So everything is pretty much wow. So, all right. Well, with that, I'm going to get out of here. Peace. Cheers. I will see you on the spin a little less than 23 hours from now. All right. Take care, everybody. Have a great evening, a great day. Hey, this is our May 1st um, um, edition of Astronomy Daily Live. So happy May. Happy May. We should probably look and see what's going on in the sky during the month of May. Um, Started to do that last month and didn't get very far because there's there's just so much to talk about. There's so much to see. There's so much to go through that it just can't do it all. There's just no way. But yeah, I'm going to try to um, um, pack that in a little bit more. As I said, I want this live stream to be pretty casual, pretty not in any hurry, not trying to pack in a lot of information and trying to go really fast and hurry, but just sit back and enjoy. Right? Just sit back and enjoy, share the passion. That's it. All right. Now I'm going to go. Happy May. 2018. Peace, cheers, and all of that. I'll see you tomorrow. Bye.